Hi everyone. We're going to talk about 4 different things to think about when you're writing good object-oriented code and the associated bad practice that can happen if you're not careful when thinking about some of these things. Unfortunately, I only have time for 4 today, though there are numerous things to think about when you're writing good object-oriented code. So, if you like the content of this video, hopefully I can make more of these in the future. The first item on our list is making sure that when you write your code, it is dry. So when we mean dry code, what that stands for is don't repeat yourself. Folks who follow the dry principle often then have the antonym of dry, which we'll call wet in this case, and they say that wet code means you're writing everything twice. That's a pretty funny way of describing the opposite, right? So when you think about writing dry code, what you want to do is you want to limit code duplication. Now, abstraction and code duplication aren't the same thing, and we'll go into that here in a little bit, but basically what I want to get at here is dry code is a good principle to follow, but you don't want to follow it to the extreme that you have now overly abstracted your software and nobody can understand it. I'll pull up IntelliJ and give an example of dry versus wet code real quick. Alright, so in IntelliJ, I've got a main class and a sample class. The sample class is just going to have a couple of static utility methods in order to prove the point of dry versus wet code. So I'm going to go ahead and create 2 static methods. The first one is going to take an integer and return that integer to the 3rd power. And the second static method is going to do the same thing, except it's going to return the integer to the 5th power. So I'll make a public static int. We'll go ahead and call it power 2. And then what we'll do is we'll have return value, and then we'll make a for loop. We could use a math library. I'm not going to do that just for the purposes of demonstration here. Okay, so now we're going to want to do retval times equals number, and then we're going to return retval. Okay, so if I were 0, so 0 would be 1. If I were 1, now you multiply it by itself there. Okay, so this should be good. Okay, so now basically what I'm going to do is I'm going to copy all this code, and I'm going to now say power 5, and I'm going to change that number out. Let's go ahead and make sure that this works. Let's say system.out sample.power2 of 2 versus power 5 of 2. All right, so as we expect, 2 to the 2nd power is 4, 2 to the 5th power is 32. So this code does work. However, I'm repeating myself within the body of these methods here. So if I wanted to make this dry code rather than wet code, what I could do is I could copy this guy, and I could just call it power. And then I could change this. Now I delete some duplicate code. Now we'll run this. And we get the same thing. So this is a pretty simple example, but it demonstrates the concept of the dry principle. So when I go into my sample.java, I have a single power method within here. And you might be thinking, well, okay, Will, you're not really doing error checking. Yeah, I know. This code, it could be very easily broken. That's not the point. The point is that previously I had 2 different methods that were doing very, very similar things. And by just adding this one parameter here, I simplified it down to 1 method, and I made the interface a little bit easier to work with, so I'm not having to sift through all these different methods and figuring out which one specifically I need. Now, that's all great and dandy, and the dry principle is typically a good thing, but do remember it is a principle. And what I mean by that is, let's say that you had a power function and you needed to have an integer version, a float version, a double version. And what you do is you have a double version, and then you somehow have a boolean to indicate whether it's an int or a float version, and now you cast them down to ints or floats so that you have different levels of precision. And now you're going, and your power function here has a whole bunch of arguments listed in here. When you get to that point, you really need to ask yourself, am I meeting the intent of the dry principle by making the code easier to maintain, or am I just adding unnecessary abstraction? So, word of the wise, the dry principle is great. It is a principle, though. Don't take it too far. Don't prematurely optimize your code. That is the root of all evil, as many would say. And what you'll also hear some people say is unnecessary abstraction is a lot harder to deal with rather than one area of duplicated code. So while I agree that the dry principle is great and you should use it, do use it with caution, and don't let it be something that you run to prematurely, and have it be something that you are considering while you're developing your code, but it doesn't need to be at the forefront of every single code design question. All right, so the second thing we're going to talk about is inheritance versus composition. What do I mean by that? Well, when you think about how you organize your data members within your classes, are you inheriting common information from base classes, or are you taking components from other classes and kind of tacking them on to your other class that you're making? 9 times out of 10, you're probably going to want to use composition. And that's because when you use inheritance, you deal with something called very tight coupling of your code. So for example, let's say that I have an inheritance structure. I have a car, and then I have Ford, I have Toyota, I have Chevy, etc. If I change something about car, I'm now changing all of my subclasses. And in the case of a true inheritance relationship, that's great. That's what you need to be doing. But you do need to ask yourself, if I make a change in this base class, will the ripple effect that comes down in all my subclasses work out? And is that really something I want? So the easy question you can ask yourself is, when you're thinking about inheritance, you should ask, is my class ISA? That is the very clear thing to be thinking about. Is a Ford car a car? Yes, it is. Now, on the other hand, composition would be asking the question, has a, or is part of. For example, a Ford truck has 4 wheels. It has typically 4 doors, and it has an engine, and it has a fuel tank. What you wouldn't want to do is have a class called fuel tank, a class called engine, a class called tire. You wouldn't want all of those to be parent classes of a truck, because what that results in is anytime you change tire, you're now changing truck. But truck doesn't necessarily have to change if one of the tires change. All you know is that trucks have tires, but a truck is not a tire. In school, they're really big on teaching you inheritance and polymorphism, and those are really important things to know. And they have a role in writing good software, and they do have a role in software design, maintenance, longevity of your code, etc. But oftentimes I think that composition is not well enough stated. And again, easily 9 times out of 10, the answer is composition. When you are trying to pull in data into a class, you want to add on components into your class. You don't want to necessarily inherit all of the data from another class. Because again, another thing within Java is, remember that you can only inherit from one class, whereas you can implement as many interfaces as you want. So when you think about interfaces, you got to be careful that you aren't just implementing all these willy-nilly interfaces of all these things that your class has. You want your class to have an ISA relationship with any of your parent classes or interfaces that you're on contract with. Whereas when you think about composition, you want to use the has a or is part of relationship. All right, item number 3 is making sure that when you are using encapsulation, you are using encapsulation properly. So there are 2 different facets of using encapsulation properly I want to talk about. The first one is making sure that the data members that you're encapsulating have the correct access modifiers. And the second one is when you are using getters and setters, make sure that, especially with getters, that you're thinking about whether the value that you're returning is a copy of a primitive, for example, or if you're talking about returning an object reference. Those result in different behavior when the caller gets the encapsulated data. So I think those are going to be a little bit easier to explain with code, so I'm going to pull IntelliJ back up again. All right, so back to our main class and sample class. I'm going to go ahead and I'll start with the typical good practice. I'm going to make a primitive data member. I'm going to go ahead and give it a value of 6. And let's go ahead and generate getters and setters. More actions, create getter and setter. All right, cool. So public int get data, public void set data. These aren't really doing anything, but again, typically if you wanted to have good practice with your getters and setters, you would think about what the value range of your data field needed to be. And in your setter, you would validate that the input was within the valid range, or you would do some sort of error handling. In that case, I'm not going to do this just for simplicity. But generally speaking, this is the idea of what you want with encapsulation. You're using the private access modifier, and you are accessing the data publicly via this getter. And since this is a primitive type, we're going to go ahead and pass this by value and pass a copy when we return the value back. And when we use the setter, we are setting the value of the primitive here as we would expect. I'm going to go ahead and demonstrate that really quickly with some code. And as we can see, when we use the getter the first time, we get the original value of 6, which is what is initialized for the field when the sample is constructed, which by the way is happening via the default constructor because I'm not defining it and it's taking no parameters. So as a part of construction of the object, data is getting set to 6. So that's why get data returns 6 right here. Set data sets a value of 10, and then we use the getter again, and now we get the new value of 10. So this is doing everything we expect with encapsulation, albeit we could do a little bit better with our getters and setters to do some value or range checking or things like that. But for the case of simplicity, we're not doing that here. So one common bad practice with encapsulation is making this mistake. So now what I do is I have a getter and a setter, so it looks like I'm encapsulating. But then the data field I am looking at here is public. So as you can see, this code compiles, and now I've just broken the encapsulation I was striving for. My setter isn't doing anything because I'm overriding the set value of 10 with a set value of 12 directly right here. So this is a no-no. Now, I guess I do want to be careful here for a second. There are cases where getters and setters aren't the right answer. You don't always want to use them. In fact, sometimes they result in code bloat, but they really do also have their benefits. So you might be thinking, if I have a field and I don't really care about the value range, I'm not doing any error checking on it, so my getters and setters are just going to be empty like these. Do I really need them? The answer is, it kind of depends on the situation. The reason I say that is because some APIs and frameworks assume that you have getters and setters for certain fields. So when it looks for a class, it actually uses the reflection API to look through the list of methods and find setters and getters. Other times what you might see is if you have a subclass and they want to override the getter and setter, then they can do additional validation that they may choose to do. If you're really dealing with a final class or a final getter and setter and you're not going to override them, the case that you really need to deal with setting them versus just having a field that you access directly, it's kind of a wash. I mean, I'm sure that some people may have a strong opinion on that. My opinion is you should design the code as to what you need currently with the option of extending, but you don't need to design for something that's going to happen 10 years from now if you don't even know it's going to happen. So you don't need to overcomplicate your code if it's not necessary. But at the same time, you don't want to dig yourself into a hole and now you have to update your code a year later and it wasn't architected in a way that was open to future extendability. So now that we've talked about that first one, which is using that wrong access modifier, I'm going to go ahead and change that back. Now what we're going to do is we're going to deal with a reference type. I'm going to list of integer because we have to wrap object types. And yes, I do want to import that. And I'm going to make this a new array list. And yes, I want to import that as well. And now I need to change these around. All right. Then when I go here, I'll go ahead and remove these for a second. And in the sample constructor, let's go ahead and give data some values. Now let's just do get data here for a second, make sure this looks good. All right, so now we've got a list with 3 elements, 1, 4, -9. Instead of printing it out, now I want to return the value into a local variable. Sample.getData. Now, the problem comes in where if I go ahead and I change this, let's say that I want to add a value of 0 in here, and I do sample.getData again, you will notice that we have modified our original class's information outside of our class. Now, you might be asking yourself, is that really a bad thing? Well, I hate to say it, but it depends on the situation. What you really need to make sure you do is when you're encapsulating a reference type, you need to make sure that the API is clear. Is the getter returning a copy of the reference, or is it returning the actual reference? Because there are cases where you have a sample class, you want to get some data out of it, and you want to update it live. There are cases where you want to do that, but the overall concept of encapsulation is not modifying the state or exposing the internal details of particular fields to outside users. So you could argue that in ways this breaks encapsulation. So what we're going to do here is we're going to go to that getter, and we're going to create a copy of data. One way you can do that is like so. If you use the ArrayList constructor, this does what is called a shallow copy. Now, there's again an important difference. This could be a good versus bad practice discussion too, which I wasn't even intending to talk about. And that is knowing whether you're talking about a deep or a shallow copy, or not copying at all. In this case, what we're doing is a shallow copy. And the difference between a shallow and a deep copy is a shallow will go in and it'll create a new collection. But each element within the collection, the reference will be copied in, rather than creating a new instance of the reference based off of the data in the reference, if that makes sense. So what that means is if you iterate over each element within this collection, when you go in and you look at the reference that it returns, if you somehow changed data that reference pointed to, then you could still change the original list. But in our case, we're talking about integers, and at least I'm not aware of anything with an integer that is more than just a get of the value in different representations. So in my case, a shallow copy is actually probably sufficient here, and I'm just going to call that good enough. If I run this code, we should see different behavior now. All right, very good. So if you explicitly want your getter to not return a reference to your collection or to your object reference, then you need to make sure that you are performing a copy. And it is up to you whether you are looking for a shallow or a deep copy, understanding that deep copies are more expensive, but they're also safer if you want to guarantee that the caller isn't changing anything about your underlying data member. Again, decisions, and it kind of does depend on the situation, but generally speaking, if you are dealing with reference types, you need to be very clear in your API on whether you're returning the real reference or not. And a lot of the time, I would say you actually don't return the reference, but it does depend on the situation. All right, so the last principle I want to talk about is making your code solid. So if you spell out solid, S-O-L-I-D, each of those letters stands for something that's an important thing you should consider when writing good object-oriented code. The S stands for the single responsibility principle. The O stands for the open-close principle. The L stands for Liskov substitution principle. The I is the interface segregation principle. And D is the dependency inversion principle. Wow, okay, that's a lot. So if we piece each of those a little bit together, I'll talk about each of them briefly. And then Wikipedia actually has a decent little article on solids, so I'll go ahead and go to that here in a second. But the first one is the single responsibility principle. And the gist of that one is when you write a class, you need to make sure that you don't have more than one reason for your class to change. So what we mean by that is single responsibility. If your class has multiple reasons to change, that means that it has multiple responsibilities and it shouldn't be doing that. You need to keep your classes simple, and what that results in is allowing them to be more easily tested, and you have fewer bugs because you have less coupling within the details of one particular class. The other one we talked about previously, when you're thinking about dry versus wet code and you're talking about premature optimization and refactoring, is you need to think about the open-close principle. And the gist of that is open for extension, close for modification. That is a really hard balance to follow, and you will see a lot of people get that wrong. I've gotten it wrong many times, and it's something that you develop over time and you get better with, but to be honest, it's something that takes time to get better at. Ways in which that you can do that would be designing APIs in a way that you can extend portions that you want to be extended, and then areas that you don't want to be extended, you can mark them as private in the API, or you could maybe make a method final. That would prevent a subclass from further extending it. Otherwise, what you can do is if you encapsulate certain data members and not others, that would allow certain amounts of extension when you wanted to extend particular parts of the API, but then it closes modification to the areas that you don't want overly modified. The Liskov substitution principle, that one is when you're dealing with a base class and you're talking about in a language like C or C++, a pointer. Not that C really has base classes, but let's talk about C++ for a second. What you need to make sure is that when you have base class references, if you were to insert a subclass, the caller should not have any knowledge of that, and they shouldn't have to change any of their behavior. So that's the idea behind polymorphism. You should be able to have a subclass implementation come in and be injected prior to the knowledge of the user of the data even knowing about it, and the interface shouldn't have to change at all. The behavior under the hood might a little bit, but the whole point is that you should be able to substitute in subclass implementations with no problem. So actually a good example of the Liskov substitution principle is the code that we have here. The JDK designed the list interface quite well, where there are a whole bunch of subclasses of list. One of them that's very often used is array list, but I don't have to use array list. What if I wanted to use a linked list? Now if I run this code, you can see that my result is no different. So this passes that check. I substituted in a different subclass implementation. The parent class that I have here and that I'm using resulted in no behavior change. I didn't have to change anything within my main class. I just changed subclass implementations within sample. That's a great example of that substitution principle. The next one is the interface segregation principle, which really goes into the difference between inheritance and composition. And basically, what that's saying is when you have a client or you have a user of an interface, they shouldn't have to be dependent on interfaces that they aren't directly responsible for wanting. So basically, if I want to use an interface, I shouldn't have all this extra baggage of all these other things that I need to take with it. That gets into a little more detail on nested interfaces or abstract class relationships. I can go into a little more detail on that in a future video, but the concept there is you basically want to limit the burden on entity classes as much as possible. The last one is the dependency inversion principle, and really the idea there is you want to rely on abstraction and you don't want to use concrete implementations as much as possible, again with caveats. And that is, if you abstract your code way too much, then it gets difficult to read and maintain. So you do need a mix of these things, but they are good principles to follow. So if you are interested in Solid a little more, which I think is a really interesting set of code principles, Wikipedia has a pretty good article about it. It's rather short, but it does have a lot of references to the particular principles, like those listed here. If you're interested in writing good software, they'd be a good read to read eventually in your software journey. All right, and that covers the 4 different things I wanted to mention today. As I said, there are a lot of other things to think about when you're writing good object-oriented code or you're critiquing somebody's code that maybe followed some bad practices. But I only wanted to cover 4 today, otherwise this would have been a really long video. So hopefully I covered some of the ones that you guys were interested in. If you have other areas you want me to focus on, or if you had any thoughts on how this video went, please do drop a comment. I'd be really interested in seeing that. Thank you for watching this video. I hope you have a good rest of your day and hope to see you next time. Take care.